Algebra students, and so welcome to our last lesson actually for chapter 3. For this one it's looking a little different because I found some slides that are already created online through the textbooks. So in this lesson we are solving absolute value inequalities. So our objective is solve compound inequalities in one variable involving absolute value expressions. So again, we're still working with that one variable, whether it's x, y, z, so on. But this time we're going to talk about things with absolute values. So they kind of talk about what are absolute value inequalities. And we're going to actually take a look at the next page. I think there's a better graphic for this to show you kind of some of this. So here's kind of the thing that I thought was a little more helpful than the directions on that first page. So they're talking about when I want to solve absolute value inequalities. And so if you remember about talking about absolute value equations result in two different answers. Remember, if we take an absolute value and we had something kind of like, okay, oh, I hope I can draw on this. Maybe I can't. This is maybe not gonna work. I think I figured it out. Sorry for that confusion. So it's talking about the inequality of the absolute value x is less than a when obviously a is greater than 0. So remember, we can't have operations in the beginning where we have a negative because absolute value is never negative. So in that case, it has to be larger than 0. Asks what values of x have an absolute value less than a. So the solutions are going to be between negative a and a. Remember when we took actual equations, we always set them equal to the positive version and the negative version. So this is very similar to that. In the case that I had something where I have an absolute value of, or the absolute value of x is less than 5, this is going to create an and situation. So if it starts with a less than, it's going to set up an and situation. The first one is going to be the same. So if you look at that bottom part, this x, the and then it says x is less than 5. That one's completely the same. If we change it to a negative though, and we want negative 5, remember a lot of times when every time we multiply or divide or change things to a negative, we're going to have to flip that sign. So that's why we see this sign flip as well. If we have an and situation, then we have the graphs combined together. Okay, so it says less than equals less and. So less than, if it starts with the less than, it's going to be an and situation. Okay, let's keep going though. So let's start talking about one that I see right now that is a less than, okay? So here are your directions again. Solve the inequality and graph the solutions. So we have an absolute value of x minus just a regular 3 is less than negative 1. Before I can break these up into the and situation, I have to get rid of this minus 3. So that's what I'm going to do first. Okay. So this one's already preloaded for me. So what we do is we add the 3 over. Then I'm going to have that absolute value is less than 2 because negative 1 plus a positive 3. Then I can break it into that and situation, okay? So this is where I'm going to get the x is less than 2. So normally, if I just take away those absolute value bars, but if I want to put it as a negative 2, I have to flip that sign. So that's why I get an x is greater than negative 2. So when you change it to the negative version, you also flip the sign. That's probably the trickiest part to remember. So if I graph that out, I'm having an open dot at each part, open dot at negative 2, open dot at a positive 2. We talked that they're an and situation because these ones are also all compound inequalities because you always get more than one answer or a set of solutions, more than one set of solutions. And so they are going to combine here in the middle. So in a problem like this, though, we're still looking at less than. It can be less than or equal. It doesn't have to, just be less than. So we're still talking about and situations here. Again, less than, less and. That was kind of the silly phrase for it. So in this case, there is nothing outside of the absolute value bars on that left side of the equation. And so there's actually nothing I need to do quite yet until I break this into two different equations. So my first one is going to be very similar to this. I'm just going to get rid of the absolute values. I'd have x minus 1 is less than or equal to 2. Then, when I want to put it to a negative 2, though, I have to flip it. So I'd have x minus 1 is greater than or equal to negative 2. And that's what we should see pop up, but I guess I didn't. Oh, I guess it's not going to pop up. Give me a minute. Since this one's not letting me write it out, here's what we're going to do. We're going to change the focus of this video slightly. I want you to pause, or we're going to pause this video as a group. I want you to try and solve this one out on a piece of paper, and I will also show my work here, and we'll come together and we will discuss it, okay? Which I already kind of gave you some of those. So I will pause this video and we'll talk more in class here. As for this video, I'm going to continue on. So, a helpful hint here. Just as you do when solving absolute value equations, you first isolate the absolute value expression when solving absolute value inequalities. So just like I said, you want to get that absolute value by itself. No other operation should be happening outside of those bars. So for that equation that we were just looking at here, you don't get rid of that one first. Keep that because it's in that absolute value bars. Okay, if it was on something on the outside of it, that's when I want to get rid of it first before I break it into those two parts of the equation. We're going to skip a couple of these so that we can continue on, okay? So let's talk about if we end up with an OR situation. So it says that the inequality of x is greater than 5 describes all real numbers whose distance from 0 is greater than 5 units. The solutions are all numbers that are less than 5 or greater than 5. Because remember, distance is never 0. So I could have anything, that's larger than 5 or smaller than negative 5. The inequality of the absolute value is greater than 5 can be written as the compound inequality of x is less than negative 5 or x is greater than 5. So again, looking at this one because of the absolute value, since this one is greater, has a greater than symbol, once I have that absolute value by itself, means it's going to be an OR situation. Okay, so your symbol is always going to tell you what kind of situation is it. Is it an AND or is it an OR situation? So in this case, ORs are, I think, a little easier. So we are going to, you'd set this up and break it up. Again, the same thing's going to happen. You have an x is greater than 5 on this one. So I'm looking over here. That's going to stay. I just got rid of the absolute values. I'm going to get rid of the absolute value because I want this as a negative. The sign flips. So then I have an x is less than negative 5. So graphing this, again, OR situations go in the opposite direction. So that is going to show my graph down here. Let's go ahead. So this one I hope it should show out the work for it. Not overly a big fan on these slides, but thanks for being patient with it. So this one is solving the inequality and graph your solutions. So again, it is a greater than symbol or greater than or equal to symbol. So that's just going to show me, a OR situation. The first step though is I have something outside of the absolute values, which is an operation of addition, and I'm adding 14. So what I'm going to do is I'm going to use my inverse operations. I'm going to subtract 14 to both sides. Subtracting those 14, okay? These cancel out on this side, so then I have 19 minus 14, which should give me 5. I'm left with the absolute value of x is greater than or equal to 5. Then I can break it up. One of my equations should be x is is greater than or equal to 5. The other one, when I put it at negative 5, I have to flip the sign, so it's going to be x is less than or equal to negative 5. And here you can see. So that first one stays positive, the sign stays the same. When I make it a negative, I flip the sign. That's probably the other trickiest part here. So if I'm going to graph those, both of them get a closed circle 5 units away from 0. So that positive 5, that negative 5, and they're going in the opposite direction. So I could have something bigger than positive 5 or smaller than negative 5. So I think we're going to do the same thing for this next one. So let's do the same thing we did before. So we will pause this video as a group. I want you to try and solve this one out. Again, we're talking about an OR situation. So when you get to graphing, it's an OR situation. So have your paper, pencil ready, solve these out. We will come together here and we will discuss the answers. Okay, so I will talk to you here in live person. Yeah, because those ones just don't do it. Okay. One other thing I want to talk about that happens with your absolute value equations. It says when solving an absolute value inequality, you may get a statement that is true for all values of the variable. In that case, we can run into situations again where all real numbers are solutions or infinitely many solutions of the original inequality. If you get a false statement when solving an absolute value inequality, the original inequality has no solutions. So we're running into this almost everywhere we go. We can run into one solution, no solution, infinitely many solutions. This is a big theme within algebra, especially Algebra 1. So here is a specialty case that they're talking about where we're either going to get an absolute value is the inequality is going to either be all real numbers or no solution. So looking at this problem, my first step is I want to get rid of that minus 5 because it's outside of those absolute value bars. That plus 4 is inside, so I don't want to do anything with it yet. So I'm going to use my inverse operation and add 5 to each side. What happens when I do that is then I have negative 8 plus a positive 5, which gives me negative 3. This is running into a problem because remember we talked about that absolute values are never equal to a negative. But think about this, an absolute value is greater than negative 3. Well, absolute values are always positive, so isn't the positive version always going to be greater than negative 3? Yeah. Absolute value expressions are always non-negative, therefore the statement is true. It's a true statement because it's always going to be bigger than negative 3 because it can't be negative. It's always going to be a positive version. So in this case, we end up with all real numbers or infinitely many solutions. So just because you get an absolute value by itself and it has a negative on this side, you have to look at that inequality sign. You can't just say, oh, no solutions because it's negative. It's a little different between inequalities and equal equations. So in the case, though, let's see what happens in this one. Again, I've got an absolute value. I've got an operation outside of it that I want to get rid of first. We're going to undo this operation of adding 9 because that negative or that minus 2 is on the inside. I want to keep that there. We're just going to subtract that 9 over first. Okay, what happens then is I get 7 minus 9, which is negative 2. My sign still stayed as less than, so think about it. Absolute values are always positive. Is any positive number ever going to be less than negative 2? No. So, in this case, absolute value expressions are always non-negative. Therefore, the statement is false for all real numbers because there's no possible thing that you're going to put in here that's going to result in something that's smaller than negative 2. Okay? I don't think there was much else that I wanted to discuss within here. Just the fact that talking about absolute values is the distance from 0, and distance can never be negative. So we will continue practicing these skills here in class. So I will see you then.